Welcome to Six Sigma Black Belt, Course 4, Module 4, Basic Statistics. Now let's pivot to the mechanics of Six Sigma, the statistics. One of the foundational principles of Six Sigma is data-driven decision-making. Statistics will go hand in hand with this philosophy. Let's begin by introducing some terms. A continuous distribution contains infinite data points. These distributions can take on any value at any precision and appear as a continuous curve. Many of the distributions we will showcase will be continuous. A discrete distribution is derived from countable data that has a finite number of possible values. Examples include binomial, Poisson, and the hypergeometric distribution. A population is a set of all possible outcomes from an event or experiment. We will select a sample from a population. Parameters are numerical values associated with a population. A statistic is a numerical value associated with a sample. The central limit theorem is like the flux capacitor of statistical analysis. Pertaining to the normal distribution, many of the assumptions, inferences, and generalizations we make in statistics would not be possible without the normal distribution and the central limit theorem. The central limit theorem consists of 3 points. If a random variable x has a mean mu and finite standard deviation, as the sample size increases, x bar approaches the mean mu. Standard deviation of the sample means becomes the population standard deviation divided by the square root of the sample size. And finally, the behavior of the distribution becomes more normal. Clearly, this means that we can begin with any unknown distribution. As we collect more and more data, the behavior can be approximated to a normal behavior. As an example, suppose we are looking at the distribution of heights. X bar is 30 and standard deviation is 0.1. An estimate for the standard deviation of the sample means with a sample size of 9 would be 0.1 divided by the square root of 9, or 0.033. As you can see from the visual, the resulting normal distribution will be skinnier and have a smaller dispersion. This makes sense, since each sample mean contains 9 individual data points. 9 times more data implies a higher confidence and therefore a lower standard deviation. Descriptive statistics can be broken into 3 categories: measures of central tendency, measures of dispersion, and measures of position. We will dedicate future lessons to each of these areas.